Hello, welcome back to my YouTube channel, Massa Tutorials. We see where mathematics literacy begins. Now, we are still on Math 102, Analytic Geometry and Calculus, which is the same thing as Coordinate Geometry and Calculus. Now, under that, there's a substrand treating equations of bisectors of angles between two lines. Equations of bisectors of angles between two lines, which is very, very important in coordinate geometry or analytic geometry. Now, when you talk of a bisector, or if a line is dividing an angle, right, then we can say that that line is dividing that supposed angle into two equal parts, right? Then, if a line is dividing a line segment, right, or we have a bisector, which is a line that is dividing a line segment, let's say AB, and the line segment AB is 5 centimeters, which means that that bisector is dividing the line segment AB into two equal parts. Right. So if you have the equation of bisectors of angles between two lines, we want to find for the equation or the two equations of that bisectors dividing or bisecting the supposed lines. So how can we find for the equation? So let's proceed. Kindly watch very carefully. I'll be solving just 3 examples. Stay tuned. All right, so let's see. Consider the lines L1, L, and L2. Let B1 and B2 denote the bisectors of the angles between L1 and L2. B1 and B2 form the locus of points equidistant. When you talk of equidistant, we mean equal distance, right? Equal length, equal modulus, equal magnitude. So that's the meaning of that. So equidistant from L1 and L2. Also, B1 is perpendicular to B2. So that's a symbol for perpendicular. Now we have the diagram here. B1, we can see that B1 is perpendicular to what? B2. So that's the B2, that's the horizontal line. Then the B1 is a vertical line. So it is perpendicular to what? B2. Now we can see that the two bisectors, that's B1 and B2, is bisecting the angles of these two lines. Between these two lines, L1 and what? L2. So how best can we find for the equation of B1 and B2? So now let's see how best we can find for the equation of B1 and B2. So let's start with an example. So our first example is, all right, so let's see example 1. Find the equation of the lines which bisect the angles between the lines x plus y plus 2 equals 0 and x plus 7y plus 26 equals 0. So how do we find for the equation of the lines which bisect the following lines given? So how can we find for the equation of the lines which bisect the angles between the lines given? So we have the two lines given, which is x plus y plus 2 equals 0 and x plus 7y plus 26 equals 0. So we can denote, so we start solution here. We can denote, or we can say that our L1 is such that x plus y plus 2 equals 0 and my L2 must be equal to, or is such that x plus 7y plus 26 equals 0. Now, we can denote any point on the bisectors. We can denote any point here. So we can say that point xy must be on this line as a bisector. So we can say that let xy be any point on bisectors. So, so let xy be any point on the bisector. On the bisector. So if xy is on this bisector B1, then xy is on this bisector B2, then we can find for the perpendicular distance. How best can we find for the perpendicular distance? We can find for the perpendicular distance. So we let xy be any point on the bisector, then xy is equidistant from the two lines. So if xy is equidistant from the two lines, so let's see, when you talk of equidistance, if I have this, let's say line segment AB to be, let's say 5 centimeters. If I want to bisect line AB, I step at point A, then I draw an arc above and below the line segment AB. Then I do not close my compass. I use the same radius to step at point B, then draw another arc to cut the first arc and the second arc drawn above then below line segment AB. So now, so how best can we draw a bisector to this line AB? So now with the two arcs drawn above and below the line segment AB, I can take my straight edge. Then let's say the intersection here is 1, then here is 2. So I can join them together with a straight edge. So my own is not drawn to scale, please. So now, if I have a point here, let's say P, right? This one is perpendicular, which means 90 degrees, right? So from point A to point P is the same distance from point P to point what? B. That's why we call it what? Equidistant, which means what? Equal distance. So from point A to this bisector, so let me name the bisector, let's say CD. To this bisector CD, from point A to this bisector CD, is the same distance from the bisector to point what? B. So they have equal what? Distance. So this guy is bisecting, or it is dividing the line segment AB into two equal parts. So now let's go straight to our solution. So here we have to compare our line x1, that's our line 1, then our line 2, with our general equation. So now my L1, which is such that my x plus y plus 2 equals 0. We can compare it with ax plus by plus c equals 0, which we have a being equal to 1, b being equal to 1, then my c being equal to 2. Right. So now, then my L2, we can do the same thing here. So I have it as x plus 7y plus 26 equals 0. So we compare plus c equals 0. My a equals 1, b equals 7, c equals 26. So we have this, right? So now, since we have a point on the bisector, right? So point xy. So I can say that point k, that's xy. So point k on the bisector. Then we can find for the perpendicular distance. And how do we calculate for the perpendicular distance? That's the absolute of ax1 plus by1 plus c, all divided by the square root of ax squared plus, square root of a squared plus what? B squared. Right. So we have this. So the absolute of ax1 plus by1 plus c, all divided by square root of a squared plus b squared. Now, since the bisector b1 and b2, they are doing the same job, which means they are dividing the lines or the angles between the two lines, right? So we can equate Right. So I can also find for the perpendicular distance here. So AX1 plus BY1 plus C divided by my square root of A all squared plus my B all squared. So we have this. So we just substitute in our values. So my absolute of A, my A is 1. This time around, I have to open my eyes, right? Then let's put in our x1, which is x, right? Then plus my b. My b is 1 here. Then let's say our y1 plus my c is 2. All divided by my square root of a is 1 all squared plus my b is 1 all squared, which must be equal to, I have here the absolute of a, which is 1 times, let's say our x1 plus b, which is 7 times our y1 plus c, which is 26, divided by square root of my a, which is 1 squared, plus my b, which is 7 squared. So we have this. So we have this on the board. So now we have 1 times x1. Let's omit the sub 1, right? The subscript 1. So now 1 times x, we have x. So then plus 1 times y, we have y. Then plus 2 divided by, let's take off the absolute, right? So now we have square root of 1 squared, which is 1 plus 1, right? Which must be equal to the same thing. We have x plus 7y plus 26 divided by square root of 1 plus 7 squared, we obtain 49. So we have this. Right. So now we have our x plus y plus 2 divided by, so x plus y plus 2 all divided by my square root of 2 equal to my x plus my 7y plus 26 divided by square root of 50. Right. So we have this. So now let's bring our absolute, right? So let's bring our absolute here. So let's bring our absolute. We took off our absolute. So now let's bring it back here. So I have the absolute of x plus y plus 2 divided by square root of 2. Then the absolute of x plus 7y plus 26 divided by the square root of 50. So now we can do our cross product here. We can do our cross product here. Our cross product. We can do our cross product here. So I have, so by cross product, we have this guy multiplying that. So I have square root of 50 multiplying the absolute of x plus y plus 2 equals square root of 2 multiplying the absolute of x plus 7y plus 26. So we have this. So now we can divide both sides by square root of 2. You can divide both sides by square root of 2. Square root of 2. You can divide both sides by square root of 2. So let's divide both sides by square root of 2. So I have square root of 50 divided by square root of 2. Then I have my x plus y plus 2 equals square root of 2 square root of 2 x plus 7y plus 26. So now this one goes away. Now this guy is the same thing as 50 over 25. 2 here 1 into 50, you obtain 25. And square root of 25, you obtain what? 5, right? So now, let's see. So I can get my 5 here. This multiplying x plus y plus 2 equals x plus y, x plus 7y plus 26. So we have this, right? We have this. Alright. So now, the reason why I brought the absolute is because there are two equations, so we have to get, there are two bisectors, sorry, so we have to get two equations, right? So now here, we have to consider the positive aspect of the absolute, right? So considering the positive part. So we have to consider the positive part here. So the positive part, so we have to take off the absolute. So I have 5 times x plus y plus 2 equals, I have my x plus 7y plus 26. So I'll get 5 multiplying x plus 5y plus 5y, I get 10. Multiply 2 by 5 in the expression x plus y plus 2 equals x plus 7y plus 26. Right. So now let's proceed to get our equation. All right, so let's send all these terms to the left hand side. So I have 5x minus x, then plus 5y minus 7y plus 10 minus 26 equals 0. So 5x minus x will obtain 4x. Then here we have negative 2y. Then here we get negative 16 being equal to 0. So we have this 4x minus 2y minus 16 equals 0. So that's one equation of the bisector, which is 4x minus 2y minus 16 equals 0. Now let's consider the negative part. So considering the negative part. So we are considering the negative part. So we'll get our 5 times our x plus y plus 2, which must be equal to, I get my negative of x plus 7y plus 26. You can bring the negative here. Just negate 1 here. So this one you get 5x plus 5y plus 10 equals, I have my negative x minus 7y minus 26. So we group like terms. Send all these terms to the left hand side. So I get 5x plus x plus 5y plus 7y plus 10 plus 26 equals 0. So I have 6x. Then I have plus my 12y. Then plus my 36 equals 0. So we have the equations of the two bisectors here. So they said we should find the equation of the lines which bisect the angles. So the equation, so now hence, or therefore, the equations of the lines which bisect the two lines are, we have 4x minus 2y minus 16 equals 0 and 6x plus 12y plus 36 equals 0. So that's that. So now let's do our second example, then you get it very, very well. So now let's proceed to our second example. All right, so let's see this example too. Find the equation of the lines which bisect the angles between the lines x minus 3y minus 2 equals 0 and negative 2x plus 4y minus 2 equals 0. So now, let our L1 be x minus 3y minus 2, then our L2 be negative 2x plus 4y minus 2 equals 0. So that's our lines, right? So now we can compare with our ax plus by plus equals 0. Our a is 1, b is negative 3, c is negative 2. If we come here, ax plus by plus c equals 0, right? We get our a being equal to negative 2, b equals 4, c equals negative 2. So now here, We can find for the perpendicular distance because let's denote what? A point P or X or Y on the bisector. So we can find for the perpendicular distance from the point to the line. So I can start with my L1, which is x minus 3y minus 2 equals 0. So we find for the perpendicular distance, which is that divided by square root of a squared plus b squared. And I have my L2, which is negative 2x plus 4y minus 2 equals 0. So I have my ax plus by plus c divided by our a squared plus b squared. So we have this, so we have to find for the perpendicular distance. So when we find for the perpendicular distance, they are doing the same job, so we equate them. So now we have our a being equal to 1. So 1 times x, we get our x. Then our b is negative 3. Negative 3 times y, we get negative 3y. Our c is negative 2 divided by square root of a all squared. So 1 all squared, we have 1. Then plus b all squared, which is negative 3 all squared, we get 9, which must be equal to the absolute of a, which is negative 2. Negative 2 times x, we get negative 2x. Then our b is 4, so we get plus 4y. Then our c is negative 2, so we get negative 2 divided by square root of a. A is negative 2, so negative 2 whole square, we get 4 plus b, which is 4 all square, we get 16. So we have this. So our x minus, our x minus 3y minus 2 divided by square root of 10, which must be equal to, let me bring my absolute, negative 2x plus 4y minus 2 divided by square root of, we get 20. So we have this. We have this, which is very, very simple and very, very trivial as well. So by cross product, we get this guy multiplying by this guy multiplying that. So square root of 20 multiplying x minus 3y minus 2, which must be equal to square root of 10 multiplying negative 2x plus 4y minus 2. We have that. So now we can divide 2 by what? Square root of 10. So that we can take off this guy. So we divide that x minus 3y minus 2 equals square root of 10 divided by square root of 10 negative 2x plus 4y minus 21. Right? Sorry, which is 2. It's not 21, it is 2. So now this guy can cancel that. So we get our square root of 2, right? Multiplying x minus 3y minus 2 equals away. We get negative 2x plus 4y minus 2. So we have this, which is very, very simple and very, very trivial as well. So now let's continue. So we can take the positive aspects of that. So considering the positive aspects. So considering the positive aspect or the positive part. So we are considering the positive part. So we get square root of 2 multiplying our x minus 3y minus 2, which must be equal to, I have my negative 2x, negative 2x plus 4y minus 2. So we take the positive aspect. So we multiply square root of 2x, then minus 3 square root of 2y minus 2 square root of 2. Right. Which one will equal to negative 2x plus 4y minus 2. So we have this here. So now, considering the negative part. So when we consider the negative part, you get root 2 multiplying x minus 3y minus 2 equals our negative multiplying negative 2x plus 4y minus 2. Right. So we take the same thing here, but we will negate that. Right. So root 2 times x, we get what? Root 2x minus that we multiply negative 3 root 2y minus 2 root 2 equals negative times negative 2x, we get 2x, we multiply again negative 4y, we multiply again plus 2. So we group like terms, we send all this 3 terms to the left hand side. So 2x minus 2x minus 3 root 2y and plus 4y minus 2 root 2. We have this, then minus 2 equals 0. So we factorize x out. So 2 minus 2x plus 4 minus 3 root 2y and plus negative 2 root 2 then minus 2 equals 0. So this is the equation of the second bisector. That's the equation of the second bisector. So the first bisector we had 2 plus root 2 multiplying x minus bracket will be 4 plus 3 root 2 multiplying y, then plus negative 2 root 2 plus 2 equals 0. So we considered the negative part and we had 2 minus root 2 multiplying x plus 4 minus 3 root 2 multiplying y plus negative 2 root 2 minus 2 equals 0. So now, that's that for the second example. Let's consider our last example. So example 3, find the equation of the lines which bisect the angles between the lines 4x minus 2y plus 3 equals 0 and negative 9x minus 3y minus 2 equals 0. So the same thing, we take our L1, which is 4x minus 2y plus 3 equals 0. Then our L2 should be negative 9x minus 3y minus 2 equals 0. So we compare with ax plus by plus c equals 0. So I have my a being equal to 4. So we compare their coefficients. My b negative 2c equals 3. So here to ax plus by plus c equals 0. So my a is negative 9, b negative 3, c negative 2. So we have this. So we take a point P, be on the bisector, then find for the perpendicular distance. So for my L1, which is ax plus by plus c divided by square root of a squared plus b squared equals ax plus by plus c, then square root of a squared plus b squared. So we have this. So we are finding for the perpendicular distance of this line, L1 and L2. So we have 4x plus negative 2y plus 3 divided by my a, which is 4 squared 16 plus negative 2 all squared, we get 4, which must be equal to, then now L2, we have negative 9x, then our b is negative 3y, then our c is negative 2 divided by, we have a, which is negative 9 all squared, a1 plus b, negative 3 all squared, we get 9. Right. So I have the absolute of 4x minus 2y plus 3 divided by square root of 20, which must be equal to the absolute of negative 9x minus 3y minus 2 divided by the absolute of 19. 9 plus 1, 10, 1, here 1 plus 8, which is So now here we can do our cross product. So by cross product, square root of 90 multiplies the absolute of 4x minus 2y plus 3. So square root of 90 multiplies the absolute of 4x minus 2y plus 3, which must be equal to square root of 22 multiplies the absolute of that. So we can divide both sides by square root of 20. So square root of 20, which square root of 20, square root of 20. So negative 9x minus 3y minus 2. So this one goes away. Here we get square root of 90 over 20. This one goes away. So I get square root of 9 over square root of 2. Square root of 9 we get 3 out of square root of 2. Right. So, which we can rationalize. When you rationalize the denominator, which means it is an irrational number. So when you rationalize, you multiply the irrational number by what's the numerator and the denominator itself. So we get 3 root 2 over 2. So we use that. So 3 root 2 over 2. So I have 3 root 2 over 2 multiplying 4x minus 2y plus 3, which must be equal to negative 9x minus 3y minus 2. So we have this. So now here, we can take off the denominator again, right? We can multiply 2 by 2. So we get 3 root 2 multiplying the absolute of 4x minus 2y plus 3 equals 2 is multiplying that, the absolute of negative 9x minus 3y minus 2, right? So we consider the positive part, right? So considering the positive part. So considering the positive part of that. So I have 3 root 2 multiplying 4x minus 2y plus 3 equals 2 multiplying negative 9x minus 3y minus 2. So we are considering the positive part. 3 root 2 times 4. Don't forget third. So 4 times 3 we get 12x root 2. 3 root 2 times 2, 2 3 is 6. So we have negative 6y root 2. Then 3 times 3 we get 9. Root 2 equals, we have negative 18x. Right, 2 9 18, then 6y and 4. Right. So now, all these 3 times to the left hand side. So we have our 12x square root of 2, then plus 18x, right? Then minus 6y square root of 2, then plus 6y, then plus 9 root 2, then plus 4 equals 0. So we have this. So now, let's factor our x out. So we have 12 root 2 plus 18 multiplying x. Then I can get my plus 6 minus 6 root 2, then y. Then plus my 9 root 2 plus 4 equals 0. So we have our first equation of the bisector. So now we can consider our negative part. So let's consider the negative part. So considering the negative part. So if you want to consider the negative part, still we have 3 2 multiplying 4x minus 2y plus 3, which must be equal to negative 2, right? Multiplying negative 9x minus 3y minus 2. So we have this, right? So the same thing, we have 12x, then multiplying square root of 2 minus 6y 2 plus 9. 2 equals, we get positive 18x plus 6y plus 4. So now, we send all the three terms, our right hand side here to the left hand side here. Right. So we have this. So I have my 12x root 2, sorry, minus 18x minus 6y root 2 minus 6y, then plus 9 root 2 minus 4 equals 0. So we can factorize x out. So I have my 12 root 2 minus 18x. Then we can get our negative multiplying 6y plus, sorry, root 2 here, root 2, then plus 6 multiplying y, and plus 9 root 2 minus 4 equals 0. So negative 6 root 2, you get negative 6 root 2. Then multiplying y, so y multiplies that. Negative times positive, you get negative. And plus that equals 0. So that's our second equation of the bisector. That's the second equation of the bisector. So watch it very, very carefully. It's very, very simple. That's how mathematics is. It's just the same procedure, we are using it for all the questions, right? So kindly soil your hands with more questions, right? So I believe that you've understood this topic. Thank you very much for watching. Thank you for subscribing. Thank you for watching Massa tutorials. We see where mathematics literacy begins. See you in our next videos, which is what? Circles. So now we are done with straight lines. We are proceeding with what? Circles, which is very, very another interesting topic. See you in our next video.